Happy Tuesday, everybody. Today we're going to continue talking about one-dimensional motion, and the dimension for today is horizontal. Tomorrow we're going to talk about the vertical dimension and free fall and stuff like that, but today we're going to stick with the horizontal. So before we get into the equations and what to do and whatnot, I'm going to give you what I call the list. So your xi and your xf is your initial and final position. Your vi and vf is your initial and final velocity. Your a is your average acceleration, and t is your time. The reason I say average acceleration is because all the problems we're going to be working with in this unit, or in this class for that matter, it's going to be a constant acceleration. That's your horizontal line on the graphs, if you remember. We're not going to be working with changing acceleration. That's going to get a little complicated for this class, but maybe later on you guys can learn about it. So anyways, this is the list. This is what we're going to start all our problems out with. If you remember, I told you how we solve problems in class and in real life is that we always start out with what we know. We find out what we want to know, and then we use our tools to get from one to the other. So this is going to be a list for you to figure out what you know. All right, so always start a problem off with the list. And I'll give you some tools to go with that. So always start out with this list. If you didn't have time to write it down while I was talking, that's okay. I'm actually going to go through the presentation maybe a little quicker than you guys would like, but I would recommend you listen the first time around, and then if you can't write down fast enough or whatever, play it again and then take notes. But right now, just listen. If you want to take notes, try, but I don't want you to miss anything. So let's get started. All right, so this is the list. This is what we're going to learn, and so these are going to be your tools. These are the kinematic equations for, like I said, motion with constant acceleration. So here we have our first equation, and it's what I call the little equation. If you remember, if you look at it closely, you can see that it might look familiar. This is the equation right here for acceleration. If we rearrange it, you'll get acceleration is equal to the change of velocity over time. So this is just rearranged in a way. So this should look very familiar to you. It's just simply the equation for acceleration. The big equation here, that's your final position equals your initial position plus your initial velocity times time plus 1/2 acceleration times time squared. And this is what I call the big equation. I'm not going to go into how we came about these equations. So if you want to know, we can go through it when I come back, or if you would like to check out a book and see where this all came from, that's totally fine. Go for it. But in this lecture, we're not going to go through it. So, and then finally, the last equation right here is the squared equation. So these are the three the three equations that we're going to use, and I will refer to them as little, big, and squared as we move on. So these are very good to have in your notes because, like I said, we're going to use them for the entire unit and beyond. So you have your equations, and now I'm just going to walk you through a sample problem of where we would use this equation, what we would try to figure out. So here's the problem. A rocket sled accelerates at 50 meters per second squared for 5 seconds, coasts for 3 seconds, then deploys a braking parachute, and it decelerates at 3 meters per second squared until coming to a halt. The question is, what is the maximum velocity of the rocket sled, and what is the total distance traveled? Now that's a lot to do. So what we're going to do is we're going to break it down like we do all our problems. And we're going to start with what we know, right? And we're going to write that list down, right? That's the first thing you do. We write the list down. So we'll take it step by step. And as you can see, I highlighted in red, a rocket sled accelerates at 50 meters per second squared. Right there's your first piece of information. That's your 50 meters per second squared for 5 seconds. So that's your time. Now you have two pieces of information. Moving on, and then it says it coasts for 3 seconds. So that's the first part, is it's accelerating. Now there's a second part where it's not accelerating, right? It says coasts. So you know it's not accelerating because it's at the same velocity. And if you remember the little equation, comes from acceleration, where it's the change of velocity over time. So that's 0, and it does that for 3 seconds. So then it decelerates at 3 meters per second squared, and that tells me my acceleration is -3 meters per second squared. Now remember, it's still going in the same direction. So we're just working with 1D, and it's just going in the same direction. It's not turning around or anything. But this is the third part. So we're breaking it up into 3 parts so that we can work with the constant acceleration I told you guys about, or the average acceleration, but we're going to do it in 3 parts. So this is the third part. It decelerates at 3 meters per second until it comes to a halt. That signifies that our final velocity is going to be 0, right? Because it stops, and so it's no longer moving. So what else do we know? I mean, that's not a lot of information. We have these 3 lists, and they're barely filled. Well, you know that it starts out at 0 because we can set our own coordinate system, so we're just going to say it starts out at 0. It's not moving in the beginning, so we know it's 0 meters per second, its initial velocity. Now we always know, since this is we also know that since this is a fluid motion, it's not like it's part 1 and then it stops, and then it's part 2 and then it stops. So it's just one fluid motion that we broke up ourselves into 3 parts. So we know that our initial position of the second part is going to be the final position of the first part, because it's a fluid motion and it doesn't teleport anywhere, right? And so then we know that the final velocity here is going to be the initial velocity there, again because of that fluid motion. And since we know that it's 0 meters per second squared acceleration, that our VI is going to equal VF. And then the same thing over here. We know that our initial position is the same as our final position of part 2, and our initial velocity is the same as our final velocity of part 2. So now we have all this other extra information. Right, so this is everything that we know. Wonderful. Now, what are we going to ask ourselves is, what are we looking for? So in part A, it asks what the maximum velocity of the rocket sled. Now you see here that I highlighted this one in red because we know it starts at 0, so we know that's not our maximum velocity, and it accelerates at 50 meters per second. So we have our final velocity here. Here, since there's no acceleration, we know these and this are the same as this, so that's all the same. And then in the third part, it actually decelerates, so that means its speed is going down. So we know that our maximum velocity is going to be this right here, or these 2 right here. And so part B says, what is the total distance traveled? So you know it's going to be at a final position in part 3. We started at 0, and it's one fluid motion in one direction, so the final position is going to be right here. So these are the 2 things that we want. Alright, so now we have everything that we know, and we know what we're looking for. Now let's go back to our tools, right? These are our tools. These are the tools that I give you. We have 3 equations we can use: the little, the big, and the squared. So let's take that and figure out which tool we're going to use to find out what answer of each problem. Alright, so we want to find part A. What is the maximum velocity of the rocket sled? And we already said that it was the final velocity of part 1. So I rewrote the list here for you guys, but obviously you don't have to rewrite it all the time. And so we're looking at the tools, and here's our 3 equations right here. So which one do we use? Let's look at what we have and what we can use. So in the first equation, we're looking for VF. We have VI, and we have A, and we have T. So we could very well use this because this is what we're looking for, and this is all what we have. So we don't even need to look any further. So I write the equation, I plug it in, and we have our final velocity is equal to 250 meters per second. So that takes care of part A. Now we can input that information according to what we had before. So we know our final velocity here, which we just found, is equal to our initial velocity here, which is the same as our final velocity because our acceleration is 0, and our initial velocity for part 3. So now let's do part B. What is the total distance traveled? So now we have a new set of information, or not new, but rather a more complete set of information. And this is what we're looking for. We're looking for our final position. And these are our three tools. Now, since we don't have our final position here, which is our initial position there, we can't find our final position here, and so on and so forth. So we have to do this in three parts. We have to find this one first in order to plug it in here, and then we have to find this one in order to plug it in here so we can find our final answer. So let's look at our tools again. Let's look at our first equation. We have VF, VI, A, and T. This is going to be of no use to us because we're looking for XF, and that is nowhere to be found here. So let's cross that out, and we can take it to the next one. We have XF, which is what we're looking for, and we have basically everything in here because our list is full except for our XF. So we know what equation we're going to use for the first part. We can very well use this one because we have everything here as well. For the third part, however, we have to be careful because they didn't give us a time for the last one. So we have to make sure that the equation has an XF, but it does not have a T. So let's look at this one, XF, XI, VI, T. Oh, we can't use that because we don't have a T. So let's go to the third one. That's your VF squared, VI squared, 2A, XF, and XI. So we have our XF and there's no T. So we're going to be using the big equation for the first two parts, and then we're going to be using the squared equation for the very last part to find our answer. So let's do part one. Here's everything that we know again, and here's the equation that we're going to use. We plug it in and we get 625 meters. So that's great. We found part one. Now we can plug that back into part two right here and do the same thing. Now our XI is no longer 0. Oh, let me go back for a second there. So XI is, for part one, XI is 0 and your VI is 0 even though your T is 5. That just becomes 0. It's just a simple plug and chug. So back in here, for part two, XI is no longer 0. It's 625 and your VI is no longer 0 as well. However, your acceleration is 0. So again, just a simple plug and chug in here, and then you get your answer to be 1375. So at the end of part two, you're at 1375 meters. Now for the final part, we take that answer and plug it into part three. So this is your initial position at part three, and you're looking for this. Now like we said, we're going to use the squared equation right here. We just rearrange it for XF because that's what we're looking for, and then again it's a simple plug and chug. It's you put in all the information which is right there in your list, right? So there's no room for error, or less room for error anyways, and this is going to be your final answer. So at the end of the time interval, the rocket sled had traveled 11,791 meters. So I know I went through this kind of quickly, just because I have a limited time on making this video, and I wish I could have shown you diagrams and videos, and I promise I'll try to make tomorrow's a little more interesting and have some fun stuff in there. So I hope you guys understood what I was going through. I have no problem with you guys playing it again. Take notes, take especially good notes on your list and on your kinematic equations. So you can do that. And now I'm going to give you practice with motion problems 1. Just don't worry about number 1 for that, just because I'm having a little trouble actually representing the diagrams through this program. But again, I'll do better tomorrow. If you have any questions, you can also email me. Someone did email me, and I sent them the link to this YouTube video. So you can do that, or I can send you the PowerPoint as well. Yeah, if you have any questions, just let me know. Yep, I hope that helped. Please watch it again and get your practice in. And until tomorrow, take care, everybody. Make good things happen.